Good morning, dear students. Today we're having the sixth practical lesson. It is about improper integrals. So let me remind you that improper integrals exist integrals of the second kind, of the first kind with infinite limits of integration, and integrals of the second kind where functions are unbounded, so bounds of integration, so segment of integration contains a singularity point for such functions. So first of all, we will calculate improper integrals with infinite limits of integration and or otherwise establish their divergence. Divergence means that the integral has so the infinite so equals infinity. So let's start from the first example. So we integrate calculate as usual a definite integral. So what do we have? Minus 1 over 3x cube, and with the substitutions from 1 to infinity to plus infinity. And then we so we calculate, so now we substitute, so minus, so 1 over infinity, so minus 1 over 3 here. So 1 over infinity is 0, and 1 over 1 is 1. So the result is 1 over 3. Any questions about this exercise?
No.
Okay, let's move next. 1b. So integral from 1 to plus infinity, and dx over square root from x. So doing the same. So according to table of integrals, it will be the following antiderivative. So from 1 to plus infinity, and it actually will be equal plus infinity. So yeah, because if we substitute plus infinity minus 1, it will be equal to plus infinity. And we have to conclude that integral diverges. Because it's infinite. Any questions about this exercise?
In the individual task, we also need to write that integral diverges.
Yes, so you need either calculate the integral or establish its divergence. So yeah, it is good idea to make some conclusion that you understand that this integral diverges because of infinity.
Diverges only when infinity.
Or so we also can calculate a limit of this expression. So when x approaches plus infinity. So in some cases, when the limit doesn't exist, we also conclude that integral diverges. So have I answered your question?
Yes, thank you.
Okay, let's move next. 1c. So integral from 0 to plus infinity x by e in power of minus x square dx. Let's use differential entry technique. So we will move minus x square under the differential. So if we differentiate, nothing changes. Yeah, let's verify it. Yeah, so minus 1 over 2 d minus x squared equals x dx. So now let's integrate. We actually have minus 1 over 2 e in power over minus x squared. And with substitutions from 0 to plus infinity. So when exponent approaches so when x approaches plus infinity, exponent so e in power of minus x squared approaches 0. And when x equals 0, e in power of minus x squared equals 1. So the result is 1 over 2. Any questions about this exercise?
And in individual homework, if we have the case and like in this expression, we need to write that integral does not diverge. Yes?
No, you don't have. If you have the finite result, it means that integral converges. So it's obvious. But when infinite, it would be better if you write that integral doesn't converge because yeah, so it means just you understand it. So have I answered your question?
Yes, thank you.
Okay, moving next. Or maybe more questions. Okay, no questions. So calculating the next integral or establishing its divergence. So from minus infinity to plus infinity. So 2x over x squared plus 1 dx. So what do we have? We have differential of x squared plus 1. And now integrating. Yeah, by the way, we need to also to split it by two integrals. So from minus infinity to 0 and from 0 to plus infinity. Now, let me check how I did here. Mhm. Uh, mhm. Yeah, so yeah, so it's better. So for better explanation, it is better to show it. So to write in details, no skipping. Mhm. Yeah, and let me also write down the following. So I1 equals this integral. I2 equals this integral. And let's calculate them separately. So logarithm of x squared plus 1 with the substitutions from minus infinity to 0. So when x equals 0, this logarithm equals 0. When x approaches minus infinity, it equals, so the logarithm equals minus infinity. So this integral diverges. And analogically to this, so plus infinity and 0 here, and this integral will be equal to plus infinity. So this integral I is a sum of I1 plus I2. So as both of them diverge, so it means that integral I that equals their sum also diverges as well. But if why I did it just not to calculate once more, so this minus infinity plus infinity, in order to not reduce in indeterminate forms. So any questions about this exercise?
No questions.
Yeah, so just to reminded you additivity property of the definite integral. Okay, moving to the next 1e. So 1e, we have the following integral. Minus infinity to plus infinity. So dx by x squared plus 2x plus 2. So first of all, let's extract the perfect square. So x squared, so what will we have? X plus 1 square plus 1. And actually, what do we have in the numerator? It is differential of this expression. So now let's differentiate. This is actually arctangents of x plus 1 with the substitutions from minus infinity to plus infinity. And when arctangents approaches plus infinity, when x approaches plus infinity, arctangents approaches p over 2. When arctangents approaches when x approaches max minus infinity, arctangents approaches minus p over 2. So the final answer is p. Any questions about this exercise?
No.
Okay, if no questions, moving to the next 1f. So let's remember how to integrate rational fractions. So x squared by 1 plus x. So let's use method of indeterminate coefficients. So now transform into the common denominator. Expand in brackets. Let's click. So ax squared plus ax plus bx plus b plus cx squared. Now also regrouping them. So a plus c by x squared plus a plus b by x and plus b. So nothing was lost. So now we have the following system of linear algebraic equations. It's quite simple. So a plus c equals 0, a plus b equals 0, and b equals 1. So a equals -1, then c equals 1. And now let's calculate the integral. So minus 1 over x plus 1 over x squared plus 1 over 1 plus x dx. So find an antiderivative. So it will be the following. So minus logarithm of x minus 1 over x plus logarithm of 1 plus x. With the substitutions from 1 to plus infinity. So I don't use a module here because of positive values. So what do we have here? Let's also modify, let's transform all expressions with logarithm. So x moves here, so I'm transforming the difference of logarithm to logarithm of the fraction. And now, if I substitute infinity, so here I will receive 0, because yeah, so a limit of this expression when x approaches infinity equals 1, and logarithm of 1 is 0. So 0 minus 0 actually, because if I substitute infinity here, I also receive 0, and minus so 1 minus logarithm of 2 and minus 1. So this one. Yeah, so brackets here. So the result is 1 minus logarithm of 2. Any questions about this exercise?
No.
Okay. So exercise 1 is done. Moving to exercise number 2. We have following integrals. So let's investigate them. Let's investigate the convergence of improper integrals with infinite limits of integration. So in this exercise, we don't have to calculate integrals. We only need to write down if it converges or diverges. So if in requirements so when doing individual tasks, when you have such a requirement, just investigate the integral. You don't calculate it, only check if it converges or diverges. If you see the text calculator, you have to calculate if it converges. So now only doing the investigation. So x in power, so x cube plus 1 dx. So how to investigate? Let's compare with the integral that is quite similar to this integral. So dx over x square. Yeah, so actually we know that so this integral so it converges when p greater than 1, so with the infinite with infinite bounds, and diverges when p is less or equals 1. So we will compare with this integral, so with the similar function. So how to compare? We will calculate the following limits of fraction of these functions. So x approaches plus infinity, and 1 over x square so what do we have here? Yeah, let's rewrite it. So x cubed plus 1 goes here, and x cube in the numerator. So this limit equals 1. So these functions are equivalent, and this integral converges. By the way, this function is greater than this function. So as integral of the greater function converges, the integral of less function converges as well. So now we make conclusion that integral I converges. And that's it. Okay, any questions about this exercise?
We just scroll down a bit.
Yes? Yeah, so that's actually the generic formula.
Thanks, no question.
Okay. Then, so moving to 2b. These formulas will remain for now. So, what do we have here? The integral from 1 to plus infinity, and logarithm of x square plus 1 over x dx. So this integral can be compared with this integral. And this function is less than this function. than this integrand. So let's calculate the limit. Let's use this template. So logarithm over x squared plus 1 over 1 over x. So I have the following limit of logarithm of x squared plus 1, and it equals plus infinity. So, so if this so as integral of the so with calculating this limit we just concluded then this integrand. So okay, let's write like this: f from x equals this, and g from x equals 1 over x. So as f is greater than g from x, then so this integral diverges, and this integral, so integral I converges as well. I diverges. So and this, so both these integrals diverge. So it's done. Any questions about this exercise? Okay, if no questions, let's move next to the improper integral of the second kind. So improper integral of the second kind contains singularity points. So it's integral for which integrand, so for which bounds of integration have contain singularity point. So 1 minus x squared. So when x squared equals so when x equals 1, we have singular. So we have infinity here. When x equals 0, everything is okay. So now let's calculate it and see. So this is the table integral. It is arcsine of x with the substitutions from 0 to 1. So arcsine of 1 is p over 2, and arcsine of 0 is 0. So the final answer is p over 2. So this integral converges. Any questions about this exercise? If no questions, let's move next. So we have the following integral. So dx over x squared minus 4x plus 3. And now let's first of all, let's find the perfect square. Let's transform it. So x minus 2 square and plus oh no, minus 1. Yeah. So x minus, yeah, so x square minus 4x plus 4 minus 1. Yeah, so okay. Now if we substitute 2 into this expression, so we don't have any problems. So we have a finite function, if a bounded function. If I substitute 0, I have bounded function as well. But what about x equals 1? So if I substitute 1, I will receive infinity. So the singularity point is in the middle of the segment. So from so let's split to the sum of integrals using the additivity property. So integral from 0 to 1 and from 1 to 2. So now let's calculate these integrals separately. I1 equals this integral. I2 equals this integral. So for this integral, yeah, by the way, I also can, yeah, let's write like this first of all. So let's enter under the differential for our convenience. So now doing the following. So calculating this integral 1 over 2 and logarithm of module of so 1 plus x minus 2 and 1 minus x plus 2. So from 0 to 1. Yeah, by the way, let's do like this. Yeah, lost. So a logarithm, so x minus 1 and 3 minus x. So let me check what do we have here. So let's reduce this module. So remove this module. So when I substitute here, so x minus 1. Yeah, so actually, yeah, here x minus 1 remains. So we don't have negative values here. And now let's calculate. So when x approaches minus, so when argument of the logarithm approaches infinity, so approaches 0, the logarithm approaches minus infinity. And yeah, for 0, no singularity, but we have minus infinity in this answer. And what about this integral? So actually analogical, everything is analogical. And now let's also check the bounds of integration. Oh yeah, let's check the sign here. Stop. X1. Oh no, here it must be 1 minus x. My bad. And here x minus 1, and here nothing changes, 3 minus x. With the substitutions from, yeah, questions?
But why 1 minus x
Here?
first?
Yeah. So if x minus 1, so what about, yeah, but yeah, anyway, I see what, yeah, I understood what you mean. Yeah, so we can operate with different, so we can, well, it will be the same as if we write x minus 3 here and x minus 1 here. So here must be positive and here. So non-negative here, non-negative here. So if I substitute, for example, 1 over 2, here I will receive a negative value. So that's why 1 over 1 minus x. So have I answered your question?
Yes, because we have a module. Thanks.
Yeah. And what do we have here? So if I substitute 2, so I have 0 because of logarithm of, oh no, not, yeah, but 0, yeah, logarithm of 1. And if I substitute here 1, so 0, and we will receive plus infinity. So these integrals diverge. So I diverges as well, yeah. So this integral. Any questions about this exercise? So be careful. Also take into consideration so all points of the segment of integration. Okay, if no questions, let's move to next exercise. Yeah, here is actually a mistake. I forgot to look into the middle of the segment. So if we didn't have such singularity point, it would have been proper integrals, but it isn't. So 3c. We have the following integral from 1 to e. Dx over x by logarithm square root of logarithm of x. So now let's use differential entry technique. So we have differential of logarithm of x. Yes, singularity point, by the way, is 1 here, because so when x equals 1, we have infinite expression. For other, yeah, so there is no more singularity points. So the answer is the following. So 2 logarithms of x with the substitutions from 1 to e. So when substituting e, we have 1. When substituting 1, we have 0. So 1 minus 0, 2 by 1 minus 0 equals 2. Any questions about this exercise? Okay, if no questions, moving next. The following integral we have, so from 0 to 1 x logarithm of x dx. So what do we have here? Singularity point is 0. Now let's calculate, let's integrate by parts. So u equals logarithm of x, du equals dx over x, dv equals x dx, and v equals 1 over 2 x square. So now integrating. So this with following substitutions and minus 1 over 2 integrals from 0 to 1 and so x dx. And what do we have here? If I substitute 1, I will receive 0. If I substitute 0, I will have undetermined form 0 by... So I will have undetermined form 0 by infinity. So when x approaches this, so approaches 0, actually this limit equals 0. You can easily check it with calculating this integral using a hospital rule. So you will see that it is 0. Then, yeah, but anyway, let's calculate. By the way, we have some time for it. So logarithm of x by 1 over x. Yeah, we actually see that, yeah, let's not spend the time. So here we have 0. So 0 minus 1 over 4 x square with substitutions from 1 to 0. From 0 to 1. And the final answer is minus 1 over 4. Any questions about this exercise?
No questions.
Okay, if no questions, let's move next. So we will finish this exercise finally. Okay, so the following integral. So 3x square plus 2 and cube root from x square. Dx. So the singularity point is 0 here. So we need to split by 2 integrals. But first of all, let's do the following. Let's divide everything by this. So what do we have? 3. Okay, let me look here because I don't want to divide, so I don't want to divide now in my own everything. So x cubed by cube root of x and plus 2 over this expression. So here is not a correct calculation because, yeah, so the result is correct, but we need to split it by two integrals. So because 0 is singularity point and we don't know how it behaves. So I1 equals this integral, I2 equals this integral. Okay, so for this integral, yeah, by the way, let's see this antiderivative. So we have okay, so 9 over 7 x square. Stop, yeah, incorrect. And nobody told me about the mistake. And plus 6 cube roots of x. So if I substitute 0, so I will have 0. And if I substitute -1, so I have minus 9 over 7. And -6. And it will be equal to so 42 plus 9 minus 51 over 7. Oh, no, not minus, but 51 over 7. Yeah, because of my minus goes away here. Actually, this integral is calculated analogically, but here we will have 51 over 7. And the final result is I equals 102 over 7. Any questions about this exercise?
Do we need in the power of 3 in I2? 3x in the power of...
Yes. So, did you mean this? Actually, it was a mistake here. Or what did you mean?
Yes.
Yeah, so just mistake, and that was copied and pasted. Okay, so now let's calculate one more integral, and after that we will have a break and have one short exercise. So integral from -1 to 0. Yeah, here is a quite interesting case. E in power of 1 over x square dx. So the singularity point is 0 here, and that's only one singularity point. Now let's write this integral as the product of following functions. So now 1 over x multiplied by 1 over x cube and multiplied by exponent of 1 over x. What do we see here? Here is the differential of this minus differential of this function. So let's use the differential entry technique here. So we will have one differential of 1 over x, and here with minus, so don't lose it. And now let's do the substitution. So we will use few approaches in this exercise. So first of all, differential entry technique. Then we will make substitution. So then as x, and then x equals 1 over t. So when x equals -1, okay, when x equals 0, t approaches, well, x approaches 0, and it approaches -0, by the way. So because of from -1 to 0, then t approaches -infinity. So we moved from one improper integral to other improper integral. Then when x equals -1, t equals -1 as well. So let's rewrite this integral. So from -1 to -infinity here, and t by exponent of t dt. Now let's turn over this so bounds of integration, and we will remove minus. And actually, it is more convenient to integrate from less to greater. Then let's do the integration by parts. So u equals t, du equals dt, dv equals e in power of t dt, then v equals e in power of t. So t, okay, I can do like this, t by e in power of t, with substitutions from minus infinity to 1 to minus 1. In some cases, by the way, substitution can lead to the proper integral. So minus integral, so from minus 1 to, so from minus infinity to minus 1, and the integrand is e in power of t. So here, what do we have? So minus 1 minus e in power of minus 1 and minus 0, because e in power of minus infinity. Then, yeah, and so if we calculate the limit when t approaches minus infinity, we will receive 0 here. And minus e in power of t, damn it. And again, with substitutions from minus infinity to 1. So here we will have minus e in power of minus 1. Oh, minus 1. And if I substitute minus infinity, I will receive 0. So the final answer is minus 2 over e. So any questions about this exercise?
Where we write the third equality, we write derivative from 1 over x. But shouldn't we...
This equality?
Yes,
Mhm.
yes. But shouldn't we also divide by 1 over 2? Because
No, because differential of 1 over x equals minus 1 over x squared dx.
yes, I mistake. Thank you.
Yeah, you are welcome. More questions? Okay, if no questions, let's have a break for 5 minutes, and then we will solve the short exercise, and then have a rest between lessons. Okay, let's continue. So the following exercise, so analogically, we need to investigate the convergence of improper integrals of unbounded functions. So in 4a, what do we do? So we have the following integral. So from 0 to 1, square root of x and 1 minus x in power of 4 dx. So first of all, let's rewrite the integrand in the following way. So here plus x square and here minus x square, and here will be 1. Then we also can write this product, so as well as sum as a difference of squares. Plus let's write here minus x. So which part is interesting for us? Actually, this one. So let's compare with the following integral. So this integral diverges. We even calculated. Oh, no, not just a moment. Yeah, it diverges because so we come. So here we have degree. So p equals 1 over 2, and it is less than 1. So for such improper integrals, p must be less than 1. So this integral converges. And this integral, so it is this function. Actually, this is this function is less than this function. So this integral I converges as well. So any questions about this exercise? Okay, no questions. So one more. For B, now we have the following integral. So from 0 to 1. So square root from x divided by e in power of sine of x and minus 1 dx. So let's use the chain of infinitesimal equivalent functions. Okay. Using this chain, so when x approaches 0, so sine of x approaches x. So we'll have this equivalent expression. Then this so x e in power of x minus 1 is equivalent to x, and it is equal to 1 over square root of x, and the integral of this integral converges because p equals 1 over 2, and it is less than 1. then initial integral I converges as well. Any questions about this exercise? About the whole lesson, about previous lessons, maybe individual tasks?
No question.
Okay.
But
Yeah.
but they can appear.
Yes, and always feel free to ask me. Everyone who asks me questions, who texts by email, everyone knows that I answer. So have a nice day, stay safe, thank you for your attention.
Thank you. Goodbye.
Goodbye.
Bye.